Hello friends, this video on chemical bonding part 29 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 28. So the molecular orbital, as I told, of a diatomic molecule we will be studying now, can we have sigma, pi and delta, etc. But we'll be focusing only on sigma and pi molecular orbital. Sigma, as I told, the name suggests, is cylindrically symmetrical around the axis, where the pi molecular orbitals are not symmetrical. Correct? See this example. So this is my two atoms, atom A, 1 and atom 2. So in this case, the sigma is possible for this, as I told. This is my S orbital. There is a possibility of getting S molecular orbital from this S atomic orbital. So this is my sigma. This is my sigma 1s. This is sigma 1s star, because it is anti-bonding. Also, if you see from P also, I can, as I told, right, I can have this sigma, because this P and P are head on and they have the same molecular axis. Right, so we can have an sigma here, sigma 2p and sigma 2p star here, bonding and anti-bonding. Similarly, as I told, the other 2p, this one and this one, these 2p, they'll have a pi bonding, pi molecular orbital. So if you see this 2p, they combine to form pi bonding molecular orbital and pi anti-bonding molecular orbital. Correct? So let's see the energy level diagram for various molecular orbital. So the exception here for oxygen, neon and fluorine, the energy diagram is this, and for other molecules the energy diagram is this. So if we compare this, this is for my O2 and 2. So if you see the differences till from sigma S, sigma star S, sigma 2S, sigma star 2S is all same, but the only difference is this. In case of oxygen, neon and fluorine, my sigma 2pz is lower than pi p. I can say that sigma 2p is lower than pi 2p. So if you see here also, my first sigma 2 becomes and then pi 2p comes. But in case of other, my pi 2p come first and then sigma 2p come. Rest other things are all same. If you notice the difference from here to here, 1s is all same. The only difference is in case of oxygen, neon and fluorine, my sigma 2p comes first and then pi 2p comes. Right? In other case, my pi 2p come first and then sigma. Let's draw the electronic configuration for boron. So now if you see in this boron, we have boron molecule will have 10 electrons, right? 5 into 2, it's 10 electrons. Correct. So this theory says that molecular orbital theory, you consider as a molecular orbital in this, try to fill the electrons here. So 10, my 1s. So if you write the electronic configuration of boron, it is 1s2, 2s2, and then 2p1. Right? This is the electronic configuration of boron atom, not from molecule. So 1s2, let me put 2 electrons here. And then 2s2, let me put this electron here, and 2p1, this electron. Correct? See, this is the order we had for boron. We have sigma, I think we have sigma 1s, sigma 1 star, and then we have sigma 2s, 2s star, like that. Similarly, here also will have this boron 2, so this guy also will have same values, correct, because this is B2. So boron this side, boron this side. So 4 electrons we'll have to fill here. Again 4 electrons we'll have to fill here like this. now we have 2 electrons, right? So it will go first here and then first here. Obviously the same principle, first 1 electrons are filled and then only second electrons will be filled, correct? So the electronic configuration for this will be what? So it will be, if you see, it will be sigma 1s2, then we have sigma star 1s2, this guy, then we'll have sigma 2s2, this guy, then we'll have sigma star 2s2, then we'll have pi 2p, you can say that 2p2, you can say that pi 2p2, correct? One each, or you can say that pi 2px1, and then you can say pi 2py1. Both are same actually, it doesn't matter, correct? And now if you see, this has to be paramagnetic. Okay, we'll discuss later. This is my electronic configuration. Let's take another example. Carbon. So carbon is C2 molecule is 2 carbon atom. One carbon atom is atomic number is 6. 1s2, 2s2, 2p2. So let's put here 1s2, 2s2 and 2p2. Similarly here also 1s2, 2s2 and 2p. Let's fill it now. We have 4 electrons here. So let's fill the 4 electrons. 4 electrons here. Let's fill the 4 electrons. 4 electrons here. Let's fill it. 1, 2, 3 and 4. Correct? That's how I'll fill the lowest energy in this case. So what would be the electronic configuration? 1s2, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and then we have pi 2py2, and then pi 2px2, right? That will be my electronic configuration. Pretty simple. So the only thing is you should know its order. You should know the diagram of this, and then this is pretty simple. You have 1s, then you have antibonding 1s, sigma 2s, antibonding sigma 2s, pi 2p, sigma 2p, and so on. Let's write the electronic configuration of nitrogen molecules. Nitrogen molecules are nothing but 2 nitrogen atom, and electronic configuration of nitrogen is 1s2, 2s2, 2p3. Correct? So let's draw this. We'll have 1s2, 2 electrons here, 2s2, 2 electrons here, 2p3, 3 electrons here. Similarly here also we'll fill the same way, 2s2 and 2p3. Correct? Now let's fill it. 4 electrons. Let's fill this up. Again 4 electrons, 2s, sigma 2s star. Now you have 6 electrons. First will go here, second will go here, third will go here, fourth will go here, fifth will go here, and sixth will go here. Correct? Now we can write the electronic configuration pretty easy. So it is sigma 1s 2, sigma star 1s 2, it's done. Sigma 2s 2, sigma 2s 2, and then pi 2p y 2, pi 2p x 2, and then we have sigma 2p z. Easy. Let's write the electronic configuration of oxygen. So for oxygen we know the rule is different. So here my sigma 2p comes first and then pi 2p. You see, sigma comes before 2 pi. So we'll take this structure. So oxygen is molecule is nothing but 2 oxygen atom, and oxygen electronic configuration is 1s2, 2s2, 2p4. So let's put electrons here. 1s you have to put 2 electrons, 2s 2 electron, and 2p 4 electron. 1, 2, 3, 4. Similarly here also let's put that 1s 2 electron, 2s, 2 electron, and 2p, 4 electron. 1, 2, 3, and 4. Let's form this 4 electron. Let's fill this 1, 2, 3, 4. You merge these two atomic orbital to form molecular orbital with 4 electron. 4, fill 4 electrons. Now you have 8 electrons, right? From p. So let's fill 8. 1, 2, 3, 4, 5, 6, 7, and 8. Correct? So the electronic configuration will be sigma 1s 2, sigma star 1s 2, then sigma 2s2, sigma star 2s2, then we have sigma 2pz2, and then we have pi 2py2, pi 2px2, and then we have anti-bonding, right? Pi star 2py1, and then pi star 2px. This is the electronic configuration. I'm just doing more examples so that you get comfortable with the electronic configuration. Once we know how to write electronic configuration, we'll tell you how to find the different properties of molecule using the electronic configuration. Let's take the fluorine example. Fluorine also similar to oxygen. Here my 2py comes before sigma 2p, right? So fluorine also is atom is nothing but 2 fluorine molecules. So one fluorine molecule atomic configuration will be 1s2, 2s2, 2p5. So let's put that 1s2, 2s2, 2p5, 1, 2, 3, 4, 5. Here also 1s2, 2s2, 2p5, 1, 2, 3. Let's fill up 4 electrons. Very simple. 4 electrons, done. Now we have 5 plus 5, 10 electrons. Let's fill it. 1, 2, 3, 4, 5, 6, 7, 8, 9. This will be the electronic configuration of. Correct? If you want, you can write. Oh, that's okay. You can just write. Let's take the example of neon. Neon also has the same as oxygen. 2p comes before this one. Pi sigma 2 becomes before pi 2p. So neon is nothing but 2 neon molecule, 2 neon atom. So for neon, the electronic configuration is 1s2, 2s2, 2p6. So let's pull this 1s2, 2s2, 2p6. 1, 2, 3, 4, 5, 6. Here also 1s2, 2s2, 2p6. 1, 2, 3, 4, 5, 6. Merge it. 4 electrons filled. 4 electrons filled. 10 electrons. 5 plus 5. Sorry, 12. 6 plus 6, 12 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all are filled. So you can just write the electronic configuration. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.